Good morning to all of you. My deep regards to Professor Ranjan Bose and Professor Kamaljeet, Madam Shikha, and Mr. Aditya, and all the dignitaries and guests of this August gathering. So what I thought I will pitch a technical presentation, but I will do maybe for the last 5 minutes. So the way it started, that means I just want to brief you the perspective of this particular project and the activities where we are going towards or looking forward to. Right? This is something we are planning. The Indo-Australia Cybersecurity Hub. That's the target of this project. But the initial phase of the project tries to focus on what are these workshops or the symposiums why we are doing. The initial part of the project is to try to figure out or find out, right, what are the things happening in the two countries. So we already had 2 discussions in Australia where Professor Kamaljeet actually led the things, right, and I was in the presence in online, right, and in India we are doing two, three type of workshops to try to churn out that what are the research projects that are being done by the leading cybersecurity researchers in this country and Australia, right? And at the end of this year, we have to submit a report, right, in this particular ARC India, which is a collaboration platform of Australia and India. We are only one vertical of ARC, This vertical is obviously cybersecurity for the social well-being, but there are other branches of the ARC also where the other collaborators have got this funding. So this funding is between myself as the co-PI, Professor Kamaljeet as the PI, right, and Professor Deepa from IIM Kozhikode. She is also one of the co-PI. So I lead the technology side, Kamaljeet leads the business and technology together, and Madam Deepa leads the linguistic side. So our focus is that when we look into the cybersecurity aspect, right, there are influences on business, right, and nowadays a lot of content is generated by which we can actually look into some vulnerability, which can lead to some vulnerability both in the web applications and mobile applications. So for that, Professor Deepa, she is one of our collaborators, and myself will be more working on the strong technology components. So I hope that this particular discussion what we are having today, we have a lot of presenters from the leading research labs of our country and industries of our countries, and we will try to figure out that what are the directions, right, the Indian research in cybersecurity, and what are the challenges the Indian cybersecurity researchers are having, so that we can try to find out some of the 4 or 5 top level directions, where we can actually focus upon, and then we can submit this charter to the common group, and then we can looking for a bigger project and a bigger involvement of all of you, right, in that particular activity, right, and that's the entire motivation. So I hope that I have made the things clear that what we are heading towards and where we will. So at the end of today's 2 technical sessions, this is inaugural session, there are 2 technical sessions. One is pre-lunch and one is post-lunch. After these 2 technical sessions, we have a discussion session, where I will request, that means if you have time to stay back, right, and to be a part of the discussion session where we will try to summarize the discussions and try to find out that, hey, these are the 4 or 5 things what we need to plan from the Indian side, right, and these are the organizations who are playing a leading role in these particular activities, and put it as a charter, right, and submit it, So here I end the perspective part, and now if I can have some time for the technical part, because I am a technical person, right, so I always love to discuss technology, right, and let me discuss so ma'am, how much time I have? 8 minutes I have?
Yeah.
Okay, fine. So what happened? So what I will enlighten the entire audience is that means this. So the India-Australia Security Hub for Critical Applications and Infrastructure. This is my. That means cybersecurity is a big domain, right? That means we cannot tell that means I am a cybersecurity expert in all domains and all applications, right? But one of the projects I have done till date is basically focusing upon critical applications and infrastructures, funded by DST, METI, it's a Intel, TCS, etc. right? And and what I have discussed in my previous 2 lectures, right? Basically, whatever work I have done in University of Calcutta, where I have discussed about cyber risk analysis and micro-segmentation, for cyber infrastructure, which is actually a patent which is filed under the DST TEFAC, right? And these are some of the things which I can present new to the audience, because these 2 things I've already presented. So just to have a summary that what I have presented in the earlier part, we are trying to look into, my student Mainak is here, right, who is doing PhD under my supervision in University of Calcutta, where we are using some sort of text analytics model to actually figure out the vulnerabilities in the websites, right? There are 2 parts of the website in terms of the language model. One is itself the URL locator, right, which can be distracting and which can lead you to some vulnerable website. So whether we can have a sort of a sort of check or pop-up, right, which can actually try to prevent you, or whether we can put this application. Another one is the content side, right? We can actually have some sort of learning model which can go through the content of the website and try to predict that how much is the vulnerability in the content of the website, so that you have a sort of flag or sort of prediction that whether you want to intend to go to that or not. Okay. And the second thing what I discussed is this is very important now at the present era of AI and ML. We are actually putting a lot of this AI ML model on our infrastructures, right? We are training them with a large amount of data, but the data itself needs to be privacy privacy protected, right? So that's the main direction, that how we can have the privacy prevention, right, in this particular large ML models, right, which are using the infrastructures of the third parties. Okay, and that is also one of the research focus. We are just discussing research focus here. Okay, not much. Okay, the third research focus also what we are doing in the IoT domain. This is a project which is funded by TCS, right, where we are trying to develop this lightweight type of blockchain, right, in the fog. We know that there is a IoT and cloud, but we can think of some sort of lightweight infrastructure in between, right? Maybe some sort of network devices or some sort of computing nodes we can have in between, right? Those can serve as my fog, and whether they can actually secure the transaction. There are a lot of transactions going in the IoT applications. If we look into a lot of data, push and pull goes between the IoT node, right, at the front end and the cloud at the back end. So for each of the transactions, can we have a sort of say a lightweight sort of blockchain implemented, which is the main component is a fog miner. We have worked also on the developing a lightweight Merkle tree in this particular project. This is a particular work which was done a couple of years ago, and now this is a final way of patent under this DST TIFAC, where we have proposed something called the micro segmentation on the security infrastructures, based on the deep learning model. So what we do, we look into some of the features of our system features, right? And we try to predict the vulnerability, and we actually train our model, right, based on the feature set what we see in the right. This may be more on the SOC type of architectures, but this can be also aggregated to the larger abstraction also, to the other levels of systems also. This is just a proposal, right? What we try to do here is that we have a sort of, if you look into, this is an implementation scenario what we did in our lab. So we have the multiple computing nodes as a sort of distributed systems, right, which actually connect with some communication channels, right? And each of these particular nodes have a controller which is called local module, and the local module actually works on the local processing core. So these are the local processing cores or segments, from which the local module abstracts the data, and local module has a particular predictive model. Based on that, the local module actually tells that, whether this is vulnerable or not. And if it is vulnerable, we have to reschedule the tasks, because the problem in the distributed infrastructure is that you have the resource and you have a set of tasks, right? And the set of tasks needs to be scheduled on the set of resources. So once you find out the resource is vulnerable, right, you have to take it out, but when you take it out, you have to reschedule it. So the rescheduling will be done. There is an overhead, but still you can do the segmentation, and still you can make the infrastructure out of your total capacity, right? And that's safe, because the main challenge in the critical infrastructure is that That means you cannot put the system on the shutdown mode, right? You have to bypass the vulnerabilities, and this is one of the things what we try to propose. Okay. Next competencies what we have a whole lot of competencies in SOC architectures, right? And how we that means implement design SOC architecture. So there's a lot of things we have done. That means the past few years of my students. I'm not getting into details of it, but these are the ways we try to define the security infrastructure on chip, okay, which is called the crypto cores, right? We can do a soft core where we just run a crypto algorithm on the processor, right? We can have a core processor mode where we have the crypto algorithm, okay, specially done on the core processor, and the main processor works for your main routine, right? And the third is a perfect customize. Okay, that means a perfect customized system which can reduce your energy, reduce your has a latency, reduce your resource. Okay, so this is the first model what we did. I will just skip a bit. Okay, this is the first. This is a model what we did, and this was one of the first NSP network security processor from the Indian Research Group. Right, it was done in 2017 where we implemented the entire security infrastructures on the two sides. One is the client side, one is the server side, and we implemented it on FPGA, right, where we had this encryption core, we have the hashing, we have the key exchange core. And then what we tried to do, this is a suite, right? You have a lot of options of encryption, we have a lot of options of key exchange. Okay, we have a lot of options of this, for hashing, right? Okay, then what we did a sort of functional model of this, that hey, there are triggers on the users, right? Hey, if I want to, there are knobs like energy knob, the resource knob, and timing knob. These are the three main knobs what we need to control, right? So the user will give a sort of weighted values that what is their maximum weight. If it's a critical infrastructure, you don't bother about your cost, you don't bother about your energy, your time is factor, because that means you have to do that on time, right? If you are a little bit slack in the critical infrastructure, you can actually focus that, okay, that means my energy and my resource needs to be taken care. So we did a sort of model which is called the ESI index, right? Okay, right, and that also worked well, right? It was published. All these are published work. Then we work on a very interesting project, which is a high-speed data chain. This is a high-speed real data chain which works in the GSI Germany, right? This is a collaborative project between VCC and my group and University of Warsaw, where we are the first group what we did. Okay, so nuclear physics experiments or high energy physics experiments, after the collision happens, the collision interval is around 10 to the power 9. So it's a huge amount of data generated in a small amount of time. Right, you cannot do the online processing. So you take the data at the back end, right, and put it into the grid, and then you try to see what has happened. But between these detectors and the grid, there are several data chains happens, and these data chains needs to be secure. And the problem in the security is that this is in a high energy domain, so there are a lot of event upsets. A lot of memory faults are there. So how we can make a data chain which is secured, which is fault tolerant, right? And this is one of the DAC chain we have developed, implemented on FPGA, and implemented there in the GSI Helmholtz laboratory at Darmstadt. Okay, right. And last but not the least, these are some of the things which are also trying to do bio-inspired algorithm, which are a mix of AI and sensing. Right, these are also coming up in a great way on this crypto hardware and crypto sensing. Right, where we try to find out that what are the vulnerabilities of my SOC infrastructure. So we had generated some sort of sensing points in terms of the failure of the logic, in terms of the power delay, right, in terms of the delay, right, in terms of the power fluctuations. And we developed a sort of learning model which tries to predict that whether a particular core has been affected by Trojans or not. This is basically focused for Trojans, but this can be taken ahead for other type of attack scenarios also, right? And this is online. Okay, a good point is that this is not offline, this is online. So in the online, I track the parameters of my existing subsystems and try to predict that whether there is a sort of vulnerability, right? And these are published in very good work. Right. Last but not the least, this was the DRDO project what we did in 2020, where we developed a system which can try to understand, right? Okay, try to understand the cipher which is there in the black box. Okay, this can be done in two ways. One is that if I am trying to take one system from my enemy, right, I have to know what is there. Another one is also that if I'm building a system, right, I try to find that whether my enemy can puncture it. Both ways it works. Okay, if I'm designing or if I'm analyzing, both way, right, it works. So we developed a sort of test bed where we have a sort of, that means we have seen that the crypto and pattern is a little bit wide apart, because crypto tells randomness and patterns means repetition. So crypto and patterns cannot work together. But in the case of the faults, right, if we try to do some injection of the faults, then we found mathematically that there are some patterns which generates, okay, for the particular specific fault events, right, and that reveals the crypto thing which is working, that reveals the crypto signature which is working in the black box. So this was delivered to DRDO in 2020, right, where we developed a fault injector, right, and a crypto cipher, and we tried to make a classifier which can actually look into the fault injection and the signatures generated by the device and try to classify the device in what class of cipher. It is not so okay, that means it's not so easy to specify the specific cipher, but what you can do, you can at least do the class of cipher, right, and then you can know that what are the things it can do. Okay, so these are the things what we have done in our lab for the over a period of 5-8 years. Okay. Next, we are looking forward to some of the things this is the security, but trust is a sort of guarantee. The difference between security and trust is the security is something what you try to implement, right? But you have to guarantee some parameters for your applications, for your fine as a service provider, fine as a critical infrastructure system, right? So whether we can make a sort of trust model. Secondly, we are trying to use, I think Madam will speak about the Gen AI, so we are also trying to look into the large language models and orchestration, how they can influence the security both in terms of the content as well as in terms of the analysis, right? And we are looking into quantum security. We are doing some work with HCL on this, and also my group works in quantum computing. Okay, so I think that the presentation from HCL will tell that what we are doing in quantum cryptography and all these things, right? I'm lucky that I have got funded with a lot of government funding agencies and industries over the period of time, right? And these are my students. Some of them have already joined good institutes abroad, right? And some of them are still working. And I thank all my students, because this work is basically almost, I just guided them, I just motivated them. They all worked with me, right? And one of my students is there here also, Mainat. Okay? So thank you all. So any questions? Anyone want to that? So I can take one question if the time permits, ma'am.
You can take one question.
One question I can take if anyone wants to ask me. Okay. Yeah. Otherwise, I'm fine.
So you talked about the AI architecture.
Yes. Yes, sure.
You talked about the AI architecture, right? So
sure.
The architecture takes care of both model stealing as well as data poisoning, or only data poisoning?
No, it is basically data poisoning. Yeah. Perfect.
I have a couple of more questions, but I'll do it later.
Model stealing is the next level. Model stealing is the next level. Yeah. Please, one question. Yeah.
Sir, I'm very curious to know how you find this cipher type. I mean, that DRDO.
Yeah. So what happens is that means that when you inject a particular fault in a particular register, so there are the key registers and there are rounds, right? Right. So if you can inject in a particular register, right, a particular bit offset, then in different rounds when it tries to work, it will shift from the ideal, right? And that shift, that differential is a pattern. Okay, the differential is a pattern, and we exploit that differential, right, and try to close that what class of cipher it is. Okay. Yeah. Thank you.